My name is Injilia Beverly Warunto, NIM 19209069. The subject of my presentation is Remote Sensing of Environment. Introduction. Remote sensing is the acquisition of information about physical objects on the earth in order to detect and classify objects by means of reflect or emitted electromagnetic energy. There are two types: passive remote sensing and active remote sensing. Electromagnetic radiation. All objects emit and reflect electromagnetic radiation, except the idealized cases such as no emission for absolute zero and no reflection for black body. Interaction with the atmosphere and air surface. With the atmosphere, the electromagnetic radiation interacts with the atmosphere in two ways: 1. Scattering, 2. Absorption, 3. Refraction. With the surface, the electromagnetic radiation interacts with the air surface in three ways: reflection, transmission, absorption, spectral signature. Sensors. Remote sensing takes three forms: 1. Reflection of solar radiation from the air, 2. Radiation emitted from the air, 3. Reflection of the emitted radiation from the sensor. The sensor illuminates the object with its own radiation instead of the sun. Aerial camera. Aerial photography is a basic form of capturing remote sense images using an aerial camera in visible light and near-infrared spectrum. Radiometer. It is used to collect reflected or emitted radiation in a wide range of frequency. Microwave radiometer. A microwave radiometer measures energy emitted at sub-millimeter to centimeter wavelength at frequency of 1 to 1000 GHz. Radar altimeter. A radar altimeter measures the altitude using the time for microwave pulse to reflect from the air surface to the instrument. Synthetic aperture radar. A SAR uses single physical antenna gathering signal at different positions at different times. LIDAR. LIDAR, light detection and ranging, is an instrument for measuring the distance to or other properties of a target. Remote sensing platforms. There are various platforms to mount remote sensor, such as balloons, kite, rockets, helicopter, aircraft, satellite, etc. Data processing. Remote sensing usually measures the interested feature of the target object indirectly. Field observation. Field observation are carried out at or near ground, acting as ground truth in support of remote sensing analysis. Application. Remote sensing has a wide range of applications such as vegetation cover, erosion, pollution, forestry, weather, and land use, which can be imaged and tracked. Vegetation. Vegetation plays an important role in the environment. There are several types of vegetation classification, such as floristic, botanical, physiognomic, structure, life form, ecological function in ecosystem, etc. Landform. Landform remote sensing cover geology, topography, etc. Aerial photos are useful in identifying geological structure and terrain. Various drainage patterns can be derived from remote sense images. It is possible to spot linear features such as fault line, figure 4.7. Water. The deep pure water appears blue to blue-green, figure 4.8. Land use and land cover. Land use refers to use of the land surface by humans in an economic sense: agricultural, industrial, commercial, residential. And land covers so the physical earth surface, feature, lake, forest, urban. Rainfall. Rainfall may be estimated by visible, infrared, or microwave bands. Infrared and visible light instruments are capable of studying the cloud upper layer only, and thus they can provide indirect information of rain. Environmental risks. Environmental risks due to various environmental hazards is an important topic for environmental engineers to recognize and understand in order to protect human, society, and ecosystem from harm or damages at local, regional, or global scales. Hazard. Hazard is threat to life, health, property, or ecosystem, i.e., it involves something that could potentially be harmful. Environmental hazard. Hazardous waste. Hazardous waste are classified into several categories such as explosive, flammable, irritant, carcinogenic, corrosive, etc. Natural hazard. Natural hazard can be further divided into geological hazard and hydrometeorological hazard. Geological hazard examples include earthquake, landslide, avalanche, volcanic eruption. Hydrometeorological hazard examples include flood, drought, hurricane, heat wave. Environmental risks. In environmental engineering, risk is defined as the expected outcome of an environmental hazard: human injury, disease, death, economic losses, or ecosystem damages. Risk perception. Risk perception is a subjective judgment the people make about the characteristic and severity of a risk. Risk assessment. Risk assessment is an important component in risk management. Risk management. Risk management is the identification, assessment, and prioritization of risk followed by coordinated and economical application of resources to minimize, monitor, and control the probability and or impact of unfortunate events or to maximize the realization of opportunities. Risk communication. Risk communication is a complex cross-disciplinary academic field. Environmental impact assessment. An environmental impact assessment is an assessment of the possible positive or negative impact that a proposed project, e.g., reservoir, wastewater treatment plant, highway, may have on the environment, considering the environmental, social, and economic aspects. So my presentation is finished. Sorry if a lot of mistake. Thank you.